Good morning to you all. In this video, we shall be solving this exercise under section 5, week 2 of STATS303D. Now, the question says, a study was conducted to determine if a relationship exists between gender and movie preference. So we want to determine if there is a relationship between gender and movie preference. That is what we want to study or determine. We want to conduct an experiment to determine if there is a relationship between gender and their movie preference. Remember, we are dealing with gender and we are looking at movie preference. So you have to know that this data is qualitative. And whenever you see a qualitative data, then the test we are going to use is going to be the chi-square test statistic. The chi-square test statistic, which is giving us the summation of the observed values or the observed frequency minus the expected frequency, all squared divided by the expected frequency. So that is the formula. This is the test statistic we are going to use. Test statistic you'll be using because the data is qualitative. And one thing we have to know is that we are also testing for independence. We are testing for independence. Because we are testing for independence, then it means that our null hypothesis should be there is independence between gender and movie preference are independent. So there is no dependence on these two variables, and it can be stated this way: there is no relationship. There is no relationship. Let me go down and write it there. Okay, let me write it here. My null hypothesis is going to be there is no relationship between gender and movie preference. So that is for the null hypothesis. Then the alternative hypothesis, H1, it means there is going to be a dependence on the two. So we can write it this way: there is a relationship between gender and movie preference. Okay, so these are our assumptions. The null hypothesis says there is no relationship. It means that they are independent. Then the alternative says that there is some dependency between the two. So there is a relationship between the two. So now we need to test and see whether what they are saying or what our null hypothesis is, we are supposed to reject or we have to accept it. We have to fail to reject. Now, This is the contingency table. It has two rows, and it has 1, 2, 3, 4, 5. So it has 5 columns. Therefore, this contingency table is called 2 by 5 contingency table, 2 rows and 5 columns. So let us start. Since we know our test statistics to be the chi-square given by this formula, we need to look for the observed. The observed frequencies are what we have in this data. That's in the question. These are all observed frequencies. They are observed frequencies. Take note of that. These are their totals. These are their totals. These are their totals. And this 200 is called the grand total. The grand total or the overall total. Alright. Now, the next thing is to come to this part, which is the expected frequencies. Now, let's pay attention to how the expected frequencies are calculated. The formula for finding the expected frequency is row total times column total, all divided by grand total. So, for example, if I want to find the expected frequency for this, remember this one is the observed frequency, but with this same, if I want to find the expected frequency for this, what is my row total? It is 90. What is the row, the column total? It is 60. Divided by the grand total, which is 200. Then whichever value you get, it is going to be, the grand total is 60. So the final answer is going to be 27. And that is what we have here. That is what we have here. So we can do the same thing for all. When you take this one, if I want to find the expected frequency here, it is going to be the total here, 690 times 45, which is here. Then you divide by 200. So you could see that I have done all in the table here. So this is how to get the expected values or the expected frequencies. So it is this. If I take, for example, this cell is going to be the total there, which is 90 times 55. Then you divide by 200. When you take, for example, this, the total here is 110. Then here is 30 divided by 200. Then you get all these values. So all the values here in red ink are the expected frequencies. And what we have in the question, these ones are the observed frequencies. So the next thing is, now we know our expected frequencies. We want to calculate the chi-square test statistic. And we know the formula. The formula is chi-square is equal to the summation of the observed frequency minus the expected frequency all squared. Then you divide by the expected frequency. So let us tick the first one. Let me go to this and explain it here. When I tick, look at the original. Let's take the first cell. Okay, so our first cell is this. The observed frequency is going to be 10. It's going to be 10. If I come to the expected value, its expected value is 27. So if I want to use the formula observed minus expected, so it's going to be 10 minus 27. Then we square it, divided by the expected. There should be a square here. Then you divide it by the expected. We are dividing by the expected, and the expected is the 27. So when you do that, we are going to get 10.7 for this one. So that is our first chi-square value. But remember, we have not summed. That is the first part without the summation. This is what I have just calculated here. So if you want to do the same thing for this, it means we are going to use this cell 50. So that becomes my observed. Then when you come here, this is the expected. So it's going to be observed minus expected, which is going to be 50 minus 33. Then you square it, divide by the expected. The expected is our 33. And when you do that, you will get 8.76. That is what we have here. So you are going to do that for all. So when you take, for example, this one, observed is this, expected is this. So it's going to be observed minus expected. Then divided, then you square it. Observed minus expected, which is 20 minus 20.25. You square it. Then you divide by the expected, which is 20.25. So you do that for all the cells. When you do that, then we are going to get so when you do that, we now have all these values. So all these values are this part of the formula. So after getting this part of the formula, you could see that the summations are 2 here. So this formula is saying that sum all the rows. So let us sum all the rows. When we sum all the rows, it's going to be add this to this. We are adding all the rows. So we add all the rows. I have this. Then you add all this one too. You have this. So I am summing up all the rows. When you finish, sum all. So after summing all the rows, this plus this plus this plus this plus this gives you this. Then you also add this. You have this. After that, sum all the columns. So you sum this. The column becomes this and this. So you add these two, and that is the sum of the column. This plus this. So when I add 20.33 to 16.63, then then what will I get? I will be getting my chi-squared value to be 36.96. 36.96. So that is how to calculate the chi-square value. So I have it here. So you add the two, you add this, then after that you add the two. If you like, you can add all straightforward. This plus this plus this plus this plus this plus this. You add everything together, and that will give you your chi-squared value. So this chi-squared value becomes your test statistic. That becomes your test statistics. So now we know that our test statistic calculated is this. That is our test statistic is 36.96. Now we are also supposed to look for the critical value. We are supposed to look for the critical value. So how do we look for the critical value? Looking for the critical value, we know the alpha level or the level of significance A to be equal to 5%, given in the question. This is the same as 0.05. Sorry. This is the same as 0.05. So we know the alpha level to be this. So what do? We have to find our chi-squared, that's the critical value, at a significant level of 0.05 and a degree of freedom. How do we find the degree of freedom? The degree of freedom is giving us the number of rows minus 1 multiplied by the number of columns minus 1. So what is our degree of freedom? We realize that our number of rows, the number of rows was 2, and the number of columns is 5. Is 2 by 5. So it's going to be the number of rows being 2 minus 1. Then the columns is 5 minus 1. So my degree of freedom becomes 1 times 4, which is equal to 4. So that is going to be here. That is going to be here. So it means I am looking for a critical value from the chi-square with a significant level of 0.05 and a degree of freedoms to be 4. So let us go and look for that value. Yes, so when I come to the chi-squared distribution table, you could see that I have a degree of freedoms here. So I have 4 here. Then also I have a significant value of 0.05 here. So you have to pick the right significant value. Then you trace the two. The meeting point becomes this. That is my meeting point. My meeting point is this. So I can see that the value there is 9.488. 9.488. So let's go back and write that down. So our critical value is going to be 9.488. That is my critical value. 9.488. So now we have to compare this. we have to compare this to the calculated test statistic. Now, we saw that our calculated test statistic, which is the chi-squared calculated, was 36.96. But looking at the critical value is 9.488. 9.488. So we can see that the calculated chi-squared value is greater than the critical value, which is chi-squared at a significant value 0.05 and 4 degrees of freedom. The calculated one is greater than the critical value. Therefore, what will be the conclusion? Since this is greater, the calculated one is greater than the critical point, it means that there is, let's go by the null hypothesis. We said that from the null hypothesis, we said there is no relationship between gender and movie preference. But because the calculated is greater than this, then it means we have to, therefore, we reject the null hypothesis. We have to reject the null hypothesis. If the calculated one was less than the critical value, then we will fail to reject. But this time we have to reject. If you reject the null hypothesis, then what does it mean? It means that there is a relationship. Remember, the null hypothesis is saying that there is no relationship, but we have rejected it. Therefore, we rather take the alternative hypothesis, which is that there is a relationship between gender and movie preference. So when you reject the null hypothesis, then you accept the alternative hypothesis. So therefore, the alternative hypothesis will hold. So that is it. I think I wrote it down here. So this is how you write it. So reject the null hypothesis since 36.96 is significantly greater than 9.488. This is the critical value, and this is the calculated one. The calculated one is greater than the critical value, so we have to reject. And we have sufficient evidence to reject the null hypothesis. There is a relationship between gender and movie preference. So that is the conclusion. We are saying that there is a relationship between gender and movie preference because we have rejected the null hypothesis. This means that the observed differences in movie preferences between males and females are not due to chance. So that is the interpretation. Now let's go to the B part of the question. The B part is saying that in case H0 is rejected, sure, H0 has been rejected because we can see that we have rejected the null hypothesis. So now that we have rejected the null hypothesis, the question is asking us, so what does it mean? What does it mean to reject the null hypothesis? It means that there is a relationship between gender and movie preference. That is the meaning. But The question is asking us in B to determine the strength of that relationship. So now we know that there is a relationship between gender and movie preference. The question is that to what extent? Is the relationship very strong? Is it very weak? Is it moderate? Or it is just weak? So that is what we are going to do. We can do that by the help of the Cramer's vein. The Cramer's vein. So let's take note of that. Now the Cramer's vein ranges from 0 to 1. 0 indicates no association. It means there is no relationship between the two variables, and 1 will indicate a perfect association between the two variables. So it means that if your value is getting closer to 0, there is no association. But if your value calculated is getting closer to 1, then it means that there is a strong association. If it is exactly 1, then it is perfect association. So let us look at this data. The interpreting of Cramer's vein we can use to guide us. If your value is somewhere 0.00 to 0.19, then there is a weak association. From 0.20 to 0.39, weak association. This one is very weak. This one is weak. Then here is somewhere moderate. If it is between these, then there is strong. Then here is very strong. But if it is exactly 1, we use the word perfect. Perfect association. That is when it is exactly 1. And if it is exactly 0, then there is no association. So that is it. Let's move on. This is the formula for finding the Cramer's vein, which will be used to determine the strength of the association. That's the formula. This is just the chi-squared value. We have already calculated the chi-squared value. And what did we get? That was 36.96. This is our chi-squared value. Then the n. The n is the grand total. What was the grand total? It was 200. The grand total for the distribution was 200. It is found here in the table. We saw it. Yes, this is the grand total. Is 200. So that is it. Then, what is the t? The t is the smaller of the two numbers r minus 1 and c minus 1. Now remember that our contingency table is r by c, where r in our table, the number of rows was 2 and the number of columns was 5. So let's find r minus 1. R minus 1 will give me 2 minus 1, which is 1. Let's look for c minus 1. C minus 1 is 5 minus 1, which is equal to 4. Now compare these two. Which of them is the smallest? We are finding the smallest one. So the smallest one is this. Therefore, our t is 1. Our t is 1. It is the smallest, the smaller of the two numbers, r minus 1 and c minus 1. So t is equal to 1. So we can now substitute this into the formula. Therefore, our Cramer's vein is going to be square roots of the chi-squared calculated, which is 36.96. Then we divide this one by the grand total n, which is 200, times the t, which is 1. So we can evaluate that one. Then is equal to 0.43. So the Cramer's vein is 0.43. So what do we say about this value? What will be this value? Looking at the value, it is closer to 0 than closer to 1. So it will not be a strong relationship, but 4.3 is also somehow closer to 5. So we can see that there is a moderate association between gender and the movie preference. There's somehow moderate association or relationship between a gender and their movie preference. So that is it. You can see that 0.43 is somewhere here, and it means that there is a moderate association between them. Thank you.